All right, today we are continuing section 5.5, so we are going to be solving quadratic equations. This time we are going to do it by finding square roots. So hopefully we remember all those rules that we talked about with radicals and exponents and all that. We're going to skip over the warm-up for now. We'll see if we've got time to go back to it. It is a good review problem, considering we are coming up on finals, and those sorts of problems will be on our finals, but we'll jump ahead a little bit to fill in our notes first. Another way to solve a quadratic is by using the square root method. This method can be used when there is no linear or b term. So remember that bx term in the middle? If it is not there, we can use the square root method. Your goal when using this method is to get the variable by itself. So it kind of goes back to the Algebra I mentality of get x by itself. So we spent a few days going over radicals and the rules with exponents and all of that. Actually, that might be a little bit of we did more exponents than radicals. So let's review simplifying radicals. Does anybody remember how we would simplify the square root of 8? Not just 4.
4 times 2. How you do like the come on.
Perfect squares.
4 times 2 and then do all that.
Yeah, so we would make our factor tree. So if I'll just do my scratch work off to the side. For the square root of 8, we would make a factor tree for 8. What two numbers multiply to give me 8? 2 and 4. So we have to choose one factor pair to work with. We chose 2 and 4 because we would never choose a factor pair that involves 1, because that doesn't help us. We're trying to come up with the prime factorization. We're trying to factor it as far as we can to only prime numbers that would multiply up to that number. So 2 can no longer be broken down. The only option is 2 and 1. We don't ever put a 1 on a factor tree. So 4 can break into 2 and 2. Now once we do that, we're looking for pairs. Do we have any pairs? Yes, we have a pair of 2s. It doesn't matter which branch you pull from, you have a pair of 2s, and then you also have a lonely 2 that does not have a pair. So when we simplify the square root of 8, whatever had a friend comes outside, so we have a 2 on the outside, and whatever did not have a friend stays inside. So we have 2 square roots of 2. All right, on number 2, we are doing a factor tree for 27. Who can give me a factor pair for 27? Sadia. 9 and 3. Which one of those will continue to break down?
9, 3,
Well,
3.
breaks into 3 and 3. So this one is similar to the last one. Okay, we have a pair of 3s and a lonely 3. So this one is going to equal 3 square root of 3. The one that had a pair comes outside. The one that did not have a pair stays inside. When you have a pair, only one of them comes outside of the radical to represent that pair. All right, on number 3, we have the square root of 75. Sorry, the spacing's a little weird on these. I don't really know why. So we have to break down 75. Can somebody new give me a factor pair? Devin? 25 and 3. All right, and then 25 breaks into 5 and 5. 3 won't break down anymore. This time we have a pair of 5s and a lonely 3. So who can tell me how they think this one would be written? Jacob?
5 square root of 3.
Very good. So the square root of 75 turns into 5 square root 3. All right, again, I'm going to erase some of my scratch work over here so that I've got room to do more. Somebody new, tell me a factor pair for 48. Charles? 6 and 8 works. This time both 6 and 8 can be broken down further. What does 6 break into?
2 and 3.
2 and 3. What does 8 break into? 2 and 4. And 4 breaks into 2 and 2. It's kind of hard to see all the way at the bottom there. Okay, so from the 4, we have a pair of 2s. Between the 8 and the 6, we have another pair of 2s. And then what number is all alone? The 3. Why do we not use the 4? We broke it down. If you break down a number, you can just cross it off. You're not going to use a number that you broke down. Okay. We only use the numbers at the very bottoms of those branches. So this time we circled 2 pairs, which Jacob asked about that situation earlier. If we have 2 pairs, then we have a number from each of them come outside and we multiply them together. So I'll write it out kind of long ways. You don't have to write it out like this. So we had a 2 come out from the bottom pair from the 4. We have another 2 come out from the other pair in the middle. And then the 3 stays inside because it's alone. So the 2s that come outside, we multiply together to get 4. So our final answer would be 4 square root 3. Questions on number 4? Oh, it looks like it's closer to number 6. All right, on number 5, we are breaking down the number 500. Somebody I have not heard from yet, give me a factor pair. India. 50 and 10, I like that pair. What will 50 break into? Okay, we've got options, but 2 and 25 is a good option. What about the 25? 5 times 5. And then we're done with the 50 branch. We did that as much as we could. What about the 10? 5 and 2. All right, so this one we kind of have to be careful because our branches are a little scattered from each other. Remember, you can always cross out any number that we broke down so that you just ignore those. We don't use them. It's a little harder to circle our pairs this time. What do we have pairs of? 2 and 5. The 2s are hard to circle as a pair because they're so far apart. We do have a pair of 5s down here. And what's alone? There's a 5 that's alone. So who can tell me what this would come out to equal? Oh, well, thanks for raising your hand. Yes, it would be 10 root 5. Okay, we would multiply a 5 and a 2 together on the outside to get the 10, and then the 5 was left alone. Just like if you multiply things that come outside of the radical together, if you have multiple numbers that are alone and stay inside the radical, those also get multiplied back together. Okay, we have not seen that yet, and I don't think we'll see it on the next one either. So if you have multiple lonely numbers, those also just get multiplied together and stay inside. All right, finally, we are going to break down 98. Who can give me a factor pair for 98? Sadia?
2 and 49.
2 and 49. And what do we know about 49?
7 and 7.
Breaks into 7 and 7, so the square root of 98 simplifies to be 7 square root of 2. When we are solving these, so this is number 1. We'll just put them up there one at a time. Number 1 is x squared equals 289. This is probably the simplest type of example that we could get. Technically, we could solve this one the same way that we were solving them last week. We could get it set equal to 0, we could factor this, and we could solve it. But if we're using square roots to do it, we're trying to get x by itself. The only thing happening to the x right now is the squared. What operation undoes squaring? Square rooting, not dividing. It seems similar to dividing, but it's not the same. Square roots undo squares. So we are going to square root both sides. When we square root x squared, we just get x. When we square root 289, what do we get? 17. But remember that note on the front page said that solving quadratics should give us how many solutions? 2. Does anybody think they know what the other solution would be? Negative 17. Very good. When we take square roots, we should get a positive and a negative answer. So we need to remember when we're solving by square roots that after we take a square root, we should have a positive and a negative answer. These are the two answers for number 1. All right, on number 2, we have 5x squared minus 180 equals 0. We might be able to do this one by factoring, if we factor out a GCF and then hope that we have the difference of 2 squares. But on this situation, I would just go straight for solving by square roots. If there is no b term, no just plain x term, we can just get x by itself. Who can tell me what they think we should do in order to start getting x by itself? Alexis? Very good. This is going to bring back like our Algebra 1 skills. We add 180 to both sides. That leaves us with 5x squared equals 180. What would happen next?
Divide by 5.
Divide by 5. What's 180 divided by 5?
36.
So we have x squared equals 36. I'll rewrite that up here so we can see it a little better. And then what would we do, Emily?
Square root it.
Square root it. Very good. To undo the squared, we would square root. So we should get how many answers? 2. What are they? 6 and negative 6. I prefer to write x equals for both my numbers. If you were to put a comma between it, sometimes you'll see it that way. X equals 6 comma negative 6. Sometimes you'll see it x equals plus minus 6. Right? The plus or minus sign could be either positive or negative. As long as you write it one of those ways, that's fine. You should always have the x equals. Don't drop that off. Don't get lazy about it. They should all have an x equals. Questions? Concerns? Ready to continue? Oh, wonderful. All right, number 3. Let me get some of this out of the way. Number 3 is 6x squared minus 486 equals 0. I'm going to rewrite it up here so I have room to show my work. Can somebody new tell me what I should do to get x by itself? Yes. Very good. First we add 486 to both sides. So we have 6x squared equals 486. What comes next? Kaylin? Divide by 6. What is 486 divided by 6? 81. And my last step? Izzy? Square root. When we square root 81, what do we get? 9 and negative 9. Wonderful. What questions do we have? Okay. Did we all get this one copied down? Okay, number 4. Rewrote it towards the top so I've got room to show my work. Somebody I have not heard from yet. Help me out with how I should get x by itself. Or I can start picking on people. Keaton, what should I do? Add 25 to both sides. I like it. That gives us 4x squared equals 25. Who can tell me what to do next? Ian? Divide both sides by 4.
6.25.
Oh, but I don't want decimals.
Why?
Can we just square root before we divide things?
We do not square root until x squared is by itself. So I would just leave 25 over 4 as a fraction. Just leave it alone. Because when we do square root both sides, what do we get?
2.5.
No. I don't want decimals. What's the square root of 25? What's the square root of 4?
2.
So x equals 5 over 2, or x equals negative 5 over 2. Don't give them to me as decimals, just leave them as fractions. All right, on number 5, to get x by itself, what are we going to do?
Divide by 3.
Divide by 3. That gives us x squared equals 8. Next up,
Square root.
square root. This one is one that we square rooted in the review. So what's the square root of 8?
2 square root 2.
2 square root 2. But we know that one answer should be positive and the other should be
Negative.
negative. It applies when we simplify them also. So we have positive 2 root 2 and negative 2 root 2. Okay, and if you needed to, you could break down this 8 again. 2 times 4, 4 would be 2 times 2. Circle your pairs, but we just did that in the warm-ups. That's why I'm not doing it now. Questions, concerns? All right. Number 6, how am I going to get x by itself?
Add 80.
Add 80. After we add 80, what do we do?
Divide by 4.
Divide by 4. That gives us x squared equals
20.
20. When we square rooted, who can raise their hand and tell me what we got? Same volunteer. Nobody new tried it. Caden?
2, 5.
2 root 5. Very good. So if we break down 20, that gives us 5 and 4. 4 breaks into 2 and 2. So that means we get 2 square root of 5. Or we could also get negative 2 root 5. I ran myself out of room. So we could have positive or negative 2 root 5. All right, on number 7, this one looks a little bit different. Instead of just having a squared x, we have something in parentheses being squared. So the process on these is going to be a little bit different. X plus 3 squared equals 49. I give myself some space to work here. These ones are going to be different in the fact that we're not going to get x by itself before we square root it. We're going to get the parentheses being squared by themselves first before we square root it. So because the parentheses are by themselves being squared, that's what I want to undo. So we are going to go ahead and square root both sides. When I square root whatever it is that's being squared, I get that thing out. So I'm going to get x plus 3 equals, when I square root 49, what do I get?
7.
7 or
Negative 7.
negative 7. So I have to set up 2 equations here. If you see parentheses being squared, the problem's going to be a little bit different than it was when there were no parentheses being squared, when it was just x being squared. So on this type of problem, we've got to split it up and then keep solving. How am I going to solve both of these?
Subtract 3.
Subtract the 3. So I get x equals
4.
4, and I also get
Negative. 11.
negative 10.
Oh.
Okay, negative 7 minus 3 is negative 10. So those would be my two answers. So in this case, it's not just plus and minus of the same number. It's two totally different answers. All right, are the parentheses alone?
No.
Other than the fact that they're being squared.
Yes.
Okay, so the squared is the only thing happening to those parentheses. So I can go ahead and square root both sides. When I square root the left side, what do I get? Good, 2x minus 1. When I square root the 16, what do I get? 4 or negative 4. So I have to set up two different equations. Then I just have to solve both of those. Algebra 1 style. What would I do? Add 1 and then divide by 2. So I'll do that to both of them. Add 1, divide by 2. So that's going to give me a fraction on the first one of 5/2. And on the other one, what is negative 4 plus 1? Negative 3, good. And then again, divide by 2. X equals negative 3/2 or positive 5/2. You still got two answers. All right, on this one, we again have parentheses being squared. But are those parentheses being squared by themselves yet?
No.
No. So we need to get the parentheses squared by themselves before we square root.
Distribute.
So we have two ideas here. One of them is to distribute. The other is to divide by 3. We are going to go with the divide by 3 option. We do not distribute into parentheses that are being squared because that changes the problem. Okay, if the parentheses don't have the squared on it, it's fair game to distribute. But with the squared on it, we are not allowed to distribute. So we will start by dividing both sides by 3. That gives us x minus 2 squared equals 7. And then we are going to square root both sides. It doesn't come out to anything. It is a prime number. So we have x minus 2 equals the square root of 7, or x minus 2 equals negative square root of 7, not 2, 7. And then how are we going to get x by itself? Add 2 to both sides. These answers are going to look a little bit different. If you put square root of 7 plus 2, that's okay. Usually we put the square root term second. So we would have 2 plus the square root of 7. And on the other one, what do you think it would look like? X equals
5. 2 plus
Well-
-7.
Well, we could put plus a negative square root of 7, or we just put minus the square root of 7. And we would leave them there. Those ones don't come out to be pretty answers, and that's okay. If we were needing to graph it or look at a graph of this, then we could use a decimal approximation. But for these, we're just going to leave them alone. Questions, concerns? Ready for one more? Okay, so we have to get the quantity being squared alone, and then we square root, split it into 2 problems if needed. So I want you to try number 10 on your own, just see how far you can get. Remember, the parentheses need to be alone before we square root it. All right, I need to get those parentheses alone first. What am I going to do? Add how much?
4.
Add 4. When I do that, I have 2 times y plus 5 squared equals
80.
80. And then
Divide by 2.
divide by 2. 80 divided by 2 is
40.
40. And then we're ready to square root. Once the parentheses are alone, we can square root both sides. So y plus 5 equals, did anybody simplify that radical?
2 square root 10.
2 root 10, or what's my other option? Negative 2 root 10. Now these get a little tricky when we go to simplify them because people want to combine things that we're not really supposed to combine. What's going to be my last step to getting y by itself?
Adding and subtracting the 5.
Subtracting the 5. On both of them, we subtract 5.
So, y.
None of this can get combined on either of them. Kind of think about it as if it were to be a 2x and a minus 5, right? We would not combine anything here. The same thing goes when it's got a radical. So we cannot do anything with the 2 and the minus 5 or the 10 and the minus 5. It's all separate. So we would leave this as y equals negative 5 plus 2 root 10. The other one would be y equals negative 5 minus 2 root 10. And we just leave them there. I know it's not pretty, but that's what we do on these. There are decimal approximations for them. We're just not even going to mess with it. Okay? We don't want the decimals. We're just going to leave them like this. These are what are called exact answers. So they're actually more useful in most cases.